here is homework number 5, problem 2 in statics, where we have a new cell phone tower supported by 3 guy wires is being installed near the UHart campus. The dimensions are 20 meters. Where are you at? Where are you at? 20 meters. 20 meters right here. 15 meters right there. We have 4 meters here, 6 meters there, and then we have 18 meters here, so it doesn't look like that's proportional, does it? 18 meters there, and then 16 meters here, and it's 24 meters tall. The tension in the guy wire between D and C, this guy right here, is 1,100. We want to determine the vertical force exerted by the tower at that connection. All right, so I have to write out a lot of my, I didn't do the diagram here. I started to write things down though. Take spring of 21, ES110, and this is homework 5. This is problem 2. These are long problems. All right, so let me draw this thing up. Here is going to be my tower. That's going to be in the Y direction right in there. I'll kind of make my little tower as I'm coming through here. I'm not going to make him like crazy complicated here. All right, so I'm going to approximate a isometric 30 degrees. Approximate the next isometric 30 degrees this way. Let's see, kind of goes that. Probably should have extended that too. All right, so B is somewhere over here. A is somewhere over here. Just kind of like trying not to overlap my tower there. And then C is somewhere over here. So I will draw out parallel lines there. Whoop. Didn't mean to make those look like they're near each other. They could be near each other, but I'll make it just a little bit over there. Okay. So here's my parallel line to here. To there. And I can actually see through my ruler so I can see whether it's parallel or not. It's one of the nice things about the see-through Weston ruler, so you can see through it. And take in here, something like that. All right, so labeling. Here's Y. Here's X, here's Z, this is D, this is B, A, C, so we could say that this is ZOA, this is ZOB, this is ZOC, this is X, oh, and this is, by the way, that's O, XOA, XOC, this is hard to be careful in there, XOB, it's right in there, and then this is Y, YOD. And our given is going to be, let's just write the F, magnitude of CD is equal to 1,100 newtons. X OA, XOA is 15 meters, nope, 20 meters. Maybe I'll write this next to it. It'll fit it in there. X, no, that's what it is, ZOA. because there's nice pairs of them. 0A is equal to 15 meters. XOB is going to be 4 meters. And ZOB be 6 meters. Yeah. Make sure you write this down the right way, right? XOC is 18 meters. ZOC is 16 meters. Why couldn't they make them all the same? And YOD, I left out the subscripts, OD is 24 meters. Find F, I guess I'll write it out this way. FD, find the vertical force exerted by the tower on the connection pin. I think that expresses it. Okay. So let's start with an FBD. Good practice. It's not going to be exciting looking. Let's try to. I actually could probably just do these like parallel right here, but I will. These are all these forces right there, but we're going to have a force right here that I'm going to call FD. And so this is going to be the F. Let's call it CD. I'll go alphabetical. FAD, and then FBD. And the sum of the forces as a vector have to be equal 0. So I might sometimes call that an R as a reaction, not as a resultant. Remember, try to keep that reaction and resultant idea down. Right here, we're finding reactions in this case, right? Because we're doing equilibrium. So we would write out, don't worry about signs yet because we're going to keep those within the vector. I will go alphabetical here. FAD, FBD, plus FCD, plus FD is equal to 0. So now we have the methodical thing we have to take care of writing out each of these direction things. It's kind of tedious, I know. So for AD, we want to take the vector from A with respect to D. Right? So looking at our thing right here, maybe even coming up some so we could look at it the same. Look at the big picture here. We will find that in the X direction we have to go 20, and in the Y direction we have to go down a negative 24. In the Z direction we have to go a positive 15. And these are meters. And so RAD. Let me scrunch this over to the side a little bit. I want to get it all. I want to use this I want to use less paper on this. My motivation is that my binder gets bigger. Well, I could actually leave the hat on as long as I put that on there. And so let's go 20 squared plus 24 squared plus 15 squared. It's going to be equal to 20, whoops, I meant to do that, 24 atom, 15 atom, square root. We get 34.66 meters. And so we want to get our AD, and we have 20 divided by 34.66 I negative 24 divided by 34.66 J, and 15 divided by 34.66 K. And populate that in the stack at 20, and I get 0.5771. No, let me get down there. Right there I go. I want to get to 24. So I get a negative 0.6925 J, and then oops, no, I'm good right there, yeah. And then 15. I get 0.4328 K. All right, so we're going to know that the force vector is going to be the magnitude of the tension times the direction. Now we go to AC. Do we know this one? Or were we given this already? No, okay. Not AC. We want BD. So we want to go R, and now it's going to go B with respect to D, right? So B with respect to D. And in the X direction, let's see, B is still going positive, so it's going in 4 meters. Still going downwards by 24. And then in the Z direction, now it's going to be negative, right? Because we're right. Whoop. Did I write this? I wrote that wrong, didn't I? Look at that. There you go. X, Y, Z. Got that right. Okay. The Z direction is going to be a negative 6. Oh, so much chaos. And these are meters. So R, B with respect to D. Squared plus negative 24 squared plus negative 6 squared. 4 squared, 24 squared plus 6. We could write that 6 plus square root. That doesn't seem right. Oh, maybe, okay, because it's so small. It's just a little bit more than 25, and start out with 24. Okay, 25.06 meters. So it's going pretty close to being down, right? Because it's such a small thing right there. So I'm going to predict that one has a lot more tension than the other ones, I think. I think so. I may be wrong. Let's see what happens. Okay, we didn't finish this. So the direction cosines BD is going to be equal to 4 divided by 25.06 I plus a negative 24 25.06 J, and then a negative 6 over 25.06 K. All right, and so that's going to equal, let's see, enter, 4 divided over, and I get 0.1596 I plus, I'll flop them around and go 24 divided, flop it around. As predicted, that's going to be large, and I'm starting to go up diagonally, right? I should be going across with these little lines. That's why they're there. 9577 J. Oh, I hate that. Shouldn't write over there. That's why that line is there. Let's see. Stack. Move the stack. Boom. All right. And 6 divided over. And that's a 0.23. distracted by that line. 394. Don't be like me, kids. Be neater. Okay. And we know that the vector that we're going to eventually want, BD, is going to be equal to the magnitude of the tension times that direction. All right. And then lastly, we'll be able to get CD. And we'll be able to put numbers in there because we were given what that magnitude is going to be, right? So I'm going to change what I do just ever so slightly when I write this out so I can kind of skip a line from the previous one. So we want to find C with respect to D, right? So we're going to be in the negative x direction because they're going backwards that way of 18 minus 18I. Still going negative 24 down. And then in the z direction, we're positive. Positive 6. Ooh, no, come back. Don't go away. Positive 16. Thing started to go to sleep. All right. Positive 16. Okay. And these are meters. So if we're going to have C with respect to D, so 18 squared plus 24 squared plus 16 squared. Oh, I was out of the picture there. So 18 squared, 24 squared plus 16 squared plus, and I go square root. Do we get 34? Well, I started to write down 24. Almost 34 exactly. You know, I'm still a little concerned about that previous thing up here. I want to see if I did that right. Let me see if I take 16 and 24 and add them, and then take 36 and add them, and square root. Yeah, I got it right up there. Okay. So I was just thinking that's so small compared to that 24, but we're okay. So now I don't have to do this lambda thing here. I can write out, and I'll start out over here, an FCD is going to be equal to my 1,100 times my negative 18 divided by my 34I plus my 1,100 times my negative 24 divided by my 34J plus my 1,100 times my 16 divided by my 34K, and I'm going to get, I'm not sure I'll be able to use my stack effectively. I'll try it anyway. I'll go, no, shoot. That's okay. This is like close to a whole number. I think it's probably a whole number. If I had more sig figs showing on here, I'd probably find that it was a little, so anyway, I'll just go type the thing out. Why not? 18 times 34 divide, boom. And we get 582, but it's negative. Oh, got to remember that. 582.4I. It's negative because of that. Plus, so now I go 1,100, 16 times 34 divided, and this 2, nope, I made a mistake. That should be this one. Let's go to this one. 1,100, 24 times 34 divide. So it's a negative 776.5 J, and then I just previously calculated that one, and it's positive 517.6 K, and once again I ran off the side over here. Bad man, but that will be in newtons. All right, so I'm not going to be able to finish off of this right here. There's not enough space. so I will make a new sheet down here. Pad only costs $10. You get a lot for your $10. It's cheaper than most places. Okay, so this is the 4th page of this homework. I'm going to move my cursor there just a little bit, just to try to make sure that this doesn't fall asleep again. And this is ES110 in homework 5. And I need to write a homework 6 very soon. And let's see, what am I doing here? Yeah, okay. Homework 2 continued, and we're going to solve for this equation. Let me write this out again at the top right here, so then I don't have to go back and forth and up there because I'm thinking in these terms. And I think as part of this, I'm going to have to solve a simultaneous equation. So it's going to be fun to watch me try to do that live. So things to come to be entertained by is watching me fumble through as I try to solve a simultaneous equation. All right, so here is the big thing. Let's see, I'll write it out. Here's all the I's. And maybe I'll write out several lines. It's going to use more paper, that's what I'm saying. So we'll start out with FAD, and the I direction is going to be FAD times 0.5771. BD, right here, is going to be plus FBD times 0.1596. CD, oh, okay, I just recognized that. I'm going to have to do something on here. CD, actually, we have a value, and that's going to be it's going to be plus, but a negative 582.4. And there's nothing in the FD direction. In fact, we should probably have written that out early on, right up here, written out that we know that the FD is going to be equal to FD times J, right? That's in the, we know that it's going upwards in here, that's what the solution is going to be. So it doesn't show, it only shows up when we go to the J. Let's make it all on one line right here. So I'll come over here and I'll just kind of offset down here to do the J part of the thing. And so we're still going to be dealing with FD, and so this could be FD times this negative FAD, I should say, negative 0.6925, and then FBD, we're going to have plus FBD times a 0.9577, and then the FCD, we have a plus FCD times a negative 776.5. Nope, excuse me. I messed up, sorry. This is an actual value, right? So we know this value of negative 776.5, but then also we have FD, and it's going to be plus just FD by itself. All right? We'll say that's plus, right? Okay, yeah, I did that correct. Almost messed the thing up, but I was going on autopilot. I stopped thinking. And then the last one, I say the last one, we better align this, right? To show you this align. There you go. F, this is a K. So we come back up to here and go FAD. 0.4328 plus FBD. It's going to be FBD times 0.2394, And then for FCD, we have a value. I'm a little concerned about something. One of these should be negative. Oh, this one. That one should be negative. So, yeah, because that -6, I forgot that negative right in there. Boom. All right, and then this last is going to be FCD, which is the plus 517.6, right? Each one of those has to equal 0. So looking through here, we can kind of see that there's 2 unknowns in this one. There's 1, 2, 3 unknowns here. There's 1, 2 unknowns here. So we want to use the I and the K together to be able to find AD and BD, right? So the easiest way to do this, I guess, I mean, there's a number of ways you can solve when you have 2 equations and 2 unknowns. I'll go ahead and go through the ugliness, as ugly as it's going to be. FAD 0.5771 plus FBD 0.1596 plus, or is this, we could even just, I could just skip this and just write that it's equal to 582.4. I like to put in parentheses on things. Okay. So I'm going to go ahead and I'll solve for, let's say I'll solve for AD. And so that's going to be, I'll write it out. 582.4, this is going to make this video long, divided by 0.5771. Right there, yeah, that's true. Okay, then subtract, because this is going to jump over to the other side. 0.1596 divided by 0.5771 FBD, right? So let's figure out what that is. Can I use anything in my stack? I can. I can do that. 0.5771 divided. So we're going to find that's going to be 1009 minus and 0.1596, 0.5771 divided. We're going to get 0.2766 FBD, right? And then I'm going to jump to my K. And my K, I'll write this out, is FAD. I'm just rewriting it out. This seems like a waste, but it's okay. And I guess I'll add it. 517.6 equals 0. So I substitute this back in here into there. So I'm going to take a 1009 times 0.4328 minus what am I doing here? Okay, I'm going to take minus 0.2766. Is that right? Yeah, 0.2766 times 0.4328 FBD plus FBD negative 0.2394. I just keep this here for the time being. I could move it over to the other side. But let's see. What I'm going to end up with is these are going to be negative, so I could bring those over to the other side. So I'll write it in another step because I don't like making mistakes. I like to try to backtrack my mistakes. I'm an FBD right there. These two, so I have 0.4328 multiplied by that. So that's going to be here, and let me go back over to this and say yes, I am still here, I believe. And then okay, so I have that as negative, and then it's going to be combined with that 0.2394. They get added together, and then it's end up being a 0.3591, right? But they were both negative, so I can move those over to the other side of the equal sign virtually. And now these are both positive, so I'm going to use 0.4328, right? That's that, and I'm going to add it to my 517.6, which might have still been in the stack somewhere, so plus. That's end up being 954.3. So my FBD is going to be equal to, no, I got to divide. Oh, got to divide that by that. So I flip them and hit divide. So I get 2,658 newtons. Now I'm able to solve for back up here, right? So I take and find that my FAD is going to be equal to 1,009 minus 0.2766 times the 2,000. Oh boy, I'm careful here. Hope that ain't negative, because you can't push a rope, right? So we multiply it by 0.2766 times, whoosh, so we got 1,009. We subtract. Of course, I subtracted the thing out, so that's totally fine. So this cable is pretty loose here. It's 273.9 newtons. So AD is pretty loose compared to these other ones right here. Interesting. I guess but hopefully I didn't make a mistake. But anyway, now I can go back to my J up above, right? And I can solve by putting in, I'll just put the numbers in, 273.9 times my negative 0.6925 plus my FB of 2,658 times my 0.9577 negative 776.5 and plus FD, right, equals 0. So FD is a magnitude. Got a lot of numbers here. Nervous. A lot of numbers. All right, here's my, I still have this one in here. So I go 0.6925 times that. And we still have this guy in the stack. So we can, and they're negative, negative. Well, that should be a negative too, right? Is that true? That should have been a negative number. Where'd you go? Right there it is. Gotta pay attention, right? It's easy just to turn your brain off. So I combine those together. No, I haven't combined them yet. So I'm going to add them together. So there's that and that combined. And now I have 2,658.9577. So actually most of that, right? And multiply and now add together. And those were all negative, and I get a 3,512 newtons. So in this case, this is, we were asking for, let's reread the question. This is a really good thing to do. Reread the question. The vertical force exerted, okay? So we probably could We probably could answer this with just a magnitude. I don't think it's necessary that we have it be a force, but it doesn't hurt to say that this is 3,512 J newtons, because it does say by the tower on the connecting pin, right? So that kind of does imply that we want to give the thing a direction. And we are done. We could have also, instead of the J, could have put an arrow going straight up onto the thing. So this was a long one, wasn't it? About 35 minutes. Hope you don't hate me too much after that really long problem, but it's good for you. Just keep telling yourself that.